All right, so yesterday we did notes on cubic functions. So today I'm gonna give you all an assignment on this, but first a warm up, okay? Um, you're gonna need a calculator, so let's drag this over here. Oh. There we go. Okay. All right, you're gonna have a quiz next Wednesday over this stuff we've been doing on cubics, but let's try this. It says, given this equation, can you fill in the table? So I know y'all can graph and press Control T, right? So let's do that. New document, don't save, number 2, and it's 2x caret 3, go to the right, minus 5. Okay, so here's a cubic function. You'll see that it goes up, kind of flattens out, and it goes back up. So we got extras right there. We should be able to get a table by pressing Control T, and we're going to start at -2, so let's go up to that, and we can go ahead and put these on. So -2, -21, -1, -7, 0, -5, 1, -3, 2, 11. Everyone confident they can get a table? Okay. Could you sketch it? So you see it goes up through -5 and then keeps going up, so it's kind of like this, something like that. Now, we talked about this yesterday. I'll be impressed. Y'all can help me out with this. Domain and range. What did we say yesterday about the domain and range of cubic functions? How far to the left does it go? Does it stop or does it keep going? And what about to the right? So what do you call that when it goes forever both ways? There's like a little, what? Okay, so you could put negative infinity to positive infinity, or the little symbol we talk about that kind of does everything is the weird looking R. It's called all real numbers. Yeah, all real numbers. Now I'm telling you, when you're doing cubic, the ones with the, if you have a 3 in the exponent, I'm telling you, the domain is always all real numbers, okay? And the range goes down forever, it goes up forever. It's also all real numbers. Domain range should be the easiest ever during this section when we do cubic because it goes forever both ways. Okay, it's kind of like a linear function. So all real numbers, okay? So you're able to do that. What about x-intercepts? So let's go back to that graph. Press Control T again to get rid of your table. And now we can do menu, what do we press to get trace? Menu 5-1. Y'all remember that? Menu 5-1? Menu 5-1. Okay. So I can trace it over to the word to right here. Remember, another name for x-intercepts are roots, zeros, solutions. So it tells me my solution right here. Now check it out. If you ever see something weird, look. If you ever see something weird like this, that means 0, right? Yeah. If you ever see this with an E and a -12 or an E and a -14, that means 0. Okay, so that's 1.36 comma 0. That's our x-intercept. Okay. And then what about our critical points? Yesterday we learned that word critical point means a change of direction. Now, it might be kind of hard to see. Okay, but do y'all see the change of direction is right around here? Going up, kind of flattens out. going up again. That's a change of direction. So we can do menu 5.1 and go over to that change of direction right there. Now this change of direction, this critical point, happens to be on the y-axis. So it says y-intercept, and it is a y-intercept, but in this case it's also a critical point at 0, -5. So that's our warm-up. So with that information, can you do that type of stuff on an assignment for cubic? Okay. If you got a quiz, make sure you fix that first, and because I need it before you leave, you can't take it home. And then work on this, knock it out, turn it in. Check Skyward. I've been putting in grades, so it's been updated. Your tests are not in yet, but soon. All right, here we go.